All right, folks. So we're doing problems 1 through 9, right? I explained that in class, but here's a picture of it in case you don't want to just refer to this image right here. I want you to put these problems on a piece of graph paper before you enter your answer into McGraw-Hill. I think that's going to give you the practice that you need to be successful on the test. But I haven't done example 2 yet, which is how you do these, 3 inequalities, potentially a bounded feasible region, right? I did example 1. This is how you do the first 6 problems. And then let's do this one quickly. Okay, so first guy right here, I'm going to treat it like an equation. Y equals -4/3 x plus 5. So I go up to 5, put a dot down because that's the y-intercept. My slope's -4/3, so I'm going to go down by 4. 1, 2, 3, 4. Now I'm going to go to the right by 3. 1, 2, 3, because only one of the numbers can be a negative, right? If we're going to have a -4/3, I'm making the rise go down by 4 and the run go over by 3, right? Now I'm going to connect my 2 points, hopefully with a straight line. And I'm okay with you just graphing them like this, freehand. You don't really need a ruler. I think that's neat enough. But if you want one, I've got them on the back counter. Let's do the next one here real quick. Oh, no. You notice it's supposed to be a dash line. So dang it. Let me undo that real quick. And let's do a dash line there. Why is it dash? Because it's not a or equal to. It's just a less than symbol. The next one's going to be a solid line. So let's do that one real quick. Y equals x minus 2. Okay, slope of 1 and a y-intercept of -2. So let's go up 1 over 1, up 1 over 1. Let's go up 2 over 2. Okay, that just, saved myself some time here. Give me a target still. Over 2. Okay, now I'm going to connect those with a solid line on this situation, right? And same going this direction. All right, I'm not shading yet. I'm just getting the boundaries in. Hey, what's the last one? Ooh, what does x equals 1 look like? X equals 1 means all values, all points have a x value of 1. So like the point 1 comma 3 would be on the line. 1 comma 5 would be on the line. 1 comma -70 would be on the line. Doesn't matter what the y is. It matters what the x is. So if I come over here to the x-intercept, that's 1, and all of these points are on the line. Now, do I want it dashed or do I want a solid line? I want a dashed line because it is not equal to here. It's just a greater than symbol, okay? So let's start shading, and I'm going to start with this one right down here, my last one. What says I want all values that are greater than 1? I don't really probably need to do a whole lot of testing for that, right? I want the x values that are greater than 1. So let's just kind of shade in that direction, right? Oh, I wonder if it's going to be this little triangle in here. Yeah, it is, right? We saw that on the first slide. Let me change colors, and I'm going to do the next one. How about y greater than or equal to x minus 2? Okay, let's test a point out for that guy. I've never been a fan of just saying, hey, this is the way it shades. Some people say because it goes this direction, shade that way. I just figure, well, it's not that hard to test a point. I'm testing it for this line right here, and I can test out the origin. So I'm going to go 0, 0. Let's test it out. And if I stick 0 in for y, oh, I got to put my inequality in here. Greater than or equal to 0 minus 2. Is 0 greater than or equal to -2? Yes, it is. That's true. So I want to shade toward the origin for the solid line here. So let's go back to the highlighter, and I'm in yellow, and so it's just a different color here. So I'm going to shade right toward the origin there, and you can start to see that, okay, so far we have what in common? We have all of this stuff over here in common. Now we haven't done the other dash line going this way, so let's go back to the top and test out a point for that guy. I got to go back to my inequality, y less than -4/3 x plus 5, and we could test out the origin for that one, right? So test out 0 comma 0. Here we go. I put 0 in for y, -4/3 times 0 plus 5. That's 0 there, so I get 0 less than 5. Well, that's true. So for the dash line, I want to shade toward the origin also. So I don't know, that's a nice color. So let's go toward the origin here. And what is in common with all of my shading? Yeah, after I did that little shading like I just did, I think I would go back in and really darken in the feasible region. So there's just like no question about it. And so I can see that the pink, the yellow, and the blue is in this region right in here. So it's a bounded feasible region. Now, the book does this. The book takes a point that's in that region and it tests them out in all three of the inequalities. I don't really feel like that's necessary since I've already tested some points out. I know those points are working for my other inequalities. And so I don't really find it necessary to, test another point that's in that feasible region, but that's the way the book does it. So, hey, thanks for watching video number 2.